The demand for information has never been greater. From streaming services to artificial intelligence and cryptocurrencies, we need data centers to help keep us connected and our information protected. The U.S. data center construction market was valued at $7.2 billion in 2020, and it is expected to nearly double to $14.2 billion by 2026. That's approximately 98% growth in data center construction projects. We'll see this growth continue in both public and private sectors for enterprise, managed services, and cloud computing as more tech giants look to improve performance for their customers and smaller companies continue to rent space. Several emerging trends in this vertical are hyperscale data centers, co-location, and edge computing. Edge computing means that we're seeing more data centers move closer to their end users and devices with facilities at the edge of the network. Having computer power at the edge enables faster performance and lower latency because organizations don't have to move the data to larger outlying facilities to process it. Moving to the edge doesn't necessarily mean micro data centers. In fact, some of this new construction will include large co-location facilities and hyperscale data centers of 100 megawatts and more and hundreds of thousands of square feet of space. Co-location facilities, or multi-tenant data centers, are like apartment buildings. Companies like CoreSite, Digital Realty, CyrusOne, and others rent out data center services to other companies to offset the high price tag of performing these services in-house or building their own facilities. The largest trend, and first out of the blocks in data center construction, is the development of hyperscale data centers. Hyperscale data centers are massive facilities for big data-producing companies like Google, Amazon, Facebook, and Microsoft. These facilities cover a minimum of 10,000 square feet of space and thousands of servers connected to the network. There are currently over 600 hyperscale data centers in the U.S., and by 2023, we could see as many as 1,000 hyperscale facilities across the country. From the land, building switchgear, redundant chillers, generators, a data center can cost between $380 per square foot to $800 per square foot. That's a lot of wire, cable, and other electrical equipment for us to sell. These are the top companies experiencing growth and booking new projects in the next 6 years. Facebook, for example, has over 40 construction projects slated across the U.S. Google plans to spend over $7 billion, and Amazon has already spent $35 billion in Northern Virginia with 3 more data centers planned. Here are a few other examples of some data center projects in the U.S. and the big business it represents. Whether hyperscale, co-location, or other construction, you'll want to keep an eye on these major investors for big data center opportunities. So why has data center growth occurred, where it has, and where is it going? During the 1980s, the National Science Network funded several supercomputing centers around the United States, and in 1986, the agency created a TCP IP-based network called NSFNet to link those supercomputing centers together and allow researchers to log into the supercomputers and perform academic research. But NSF decided not to limit NSFNet to that purpose, allowing the network to be used for a wide variety of academic purposes. As a result, the NSFNet became the Internet's backbone, the high-speed, long-distance network that allowed different parts of the Internet to communicate. In 1994, the Clinton administration privatized the Internet backbone. Commercial firms took over the job of carrying long-distance Internet traffic, allowing the government-funded NSFNet to be decommissioned. As a result, over the last several years, we saw most of the data center construction along the major fiber trunk laid decades ago from west to east. But now, data centers are starting to branch out north and south thanks to these edge data centers. This means areas with large, undeveloped land with access to cheap utilities will be prime locations for future builds. Geographically, pay attention to these prominent data center growth areas across the U.S. This includes Northern Virginia, New Jersey, New York, Iowa, Nebraska, Texas, Arizona, Oregon, and California. While development isn't exclusive to these locations, we're currently seeing heavy activity in these areas. Now that we have an understanding of where to look for data center opportunities, we need to be hyper aware of what these customers are looking for. In the world of data centers, architects and engineers are starting to standardize their design as much as possible. They are looking for solutions that offer repeatability for speed of design, easy installation, reliable performance, and the ability to expand quickly. But this comes with its own set of challenges. Data center projects are strained by extended construction times and costs, supply chain issues, power and cooling resources, but most of all, data centers fear unscheduled downtime. The ITIC's 11th Annual Hourly Cost of Downtime Survey reported that 40% of enterprises said the cost of an hour of downtime can easily range from $1 million to more than $5 million. This challenge is compounded by the fact that data centers are heavily reliant on public utilities. Approximately 3% of all electricity used in the world is consumed by data centers. To alleviate public utility reliance, some data centers employ their own substations or renewable energy resources on site to power and cool their facilities. These facilities can be powered by solar, wind, and even geothermal sources like Switch's Citadel campus in northern Nevada. But no matter how you source power, data centers are always looking for ways to ensure full 24/7 operation. So in addition to primary power, every data center has full secondary power distribution systems in place. This built-in redundancy protects the data center from unplanned downtime. Redundant data center architecture duplicates critical components to ensure operation can continue even if a component fails, diminishing the likelihood of downtime. An automatic transfer design ensures that when one power source goes offline, capacity is instantly diverted to the designed backup unit. This resiliency greatly diminishes the likelihood of downtime, and this is where low-voltage copper wire and cable comes into play. Copper cables possess a wide range of properties that make them irreplaceable for many electrical applications. Copper is more conductive, offering lower latency, enhanced reliability, and less power consumption, which can result in lower operational costs. So let's break down this application. Secondary power distribution is a low-voltage network that carries electricity from the power supply to the servers, cooling towers, and other operations. The most common distribution systems consist of simple feeder circuits that can be overhead, underground, or a combination of both. ServiceWire's low-voltage cable is the most reliable solution to ensure 24/7 operation. Our low-voltage cable can run from the generator into waterfall cable tray. From there, it can be run in cable tray to the server floor and dropped to the busway, which powers the server racks. This is just one example of how cables might be run through a data center facility. ServiceWire's products can be used in an array of applications inside a data center to power the electrical room, overhead lighting, fire safety systems, HVAC, servers, and more. Our most popular products that we sell into data centers are no-lube ServicePlex single conductors, ServicePlex twisted multiconductor cables, tray cable, and feeder MC. ServiceWire's single conductors can be used in conduit, cable tray, duct banks, or direct buried. We offer thermoset XHHW-2 and USE-2 in 14 gauge through 1000 kc mil. All cables are CT rated, 600 volt/1 kV, copper, in all industry standard collars. Because cooling is a major issue at data centers, especially crypto mining facilities, the excessive heat generated in a data center may affect the integrity of the cable and expose critical equipment to overcurrent. Heat buildup in thermoplastic cables like THHN-2 is of major concern as data centers add more megawatts. In addition, polyvinyl chloride, PVC, contains dangerous chemical additives including lead and cadmium, which can be toxic to your health, especially when they burn. These toxic additives can leach out or evaporate into the air over time, posing unnecessary dangers to humans and to expensive electrical equipment like servers and cooling equipment. Therefore, it is important to specify thermoset cables like XHHW-2 instead of thermoplastic cables like THHN or THWN-2. THHN THWN-2 uses a PVC nylon insulation, which can break down over time and lead to current leakage and dielectric breakdown in demanding circuits or from environmental exposure. XHHW-2, on the other hand, is a cross-link product with XLPE insulation instead of PVC nylon. It is more resistant to chemicals and abrasions, and because of the chemistries involved, it is far less toxic than PVC in the event of fire or corona discharge. In data centers, the electrical systems are constantly being exposed to overcurrent 24/7. Lights, computers, HVAC, IT equipment, VFDs, all of these can contribute to overcurrent and heat buildup in the electrical wiring. THHN THWN-2 can only provide protection up to 850 volts of overcurrent, whereas XHHW-2 can handle up to 1,850 volts, thus providing better protection for your investment. Additionally, THHN's nylon outer covering can break down over time from the heat and induce contaminants into the cleanroom. XHHW-2 has XLPE insulation, which is 4 times more resistant than THHN per UL resistant testing, and can prevent such contamination. The actual insulation resistance for THHN is 700 megaohms, compared to XHHW-2's 100,000 megaohms, and after 12 weeks of operation, the insulation resistance of THHN drops to 0.85 megaohms, whereas XHHW-2 is constant at 100,000 megaohms. Another consideration is the added stress a redundant architecture puts on the electrical system. An XLPE cable, like Service Pro X, can better handle the power load, preventing damage to expensive equipment. ServiceWire's ServicePlex twisted multiconductor cable is a great alternative for multiple single runs or THHN parallels. ServicePlex easily fits into the confines of the server floor and matches the design aesthetic of mission-critical data centers. ServicePlex is a unique construction of conductors twisted together to create a consistent, uniform multi-conductor cable that pulls like a single conductor. ServicePlex reduces the number of pulls required, reduces the time it takes to execute a pull, and saves on labor, providing major savings on labor and material costs. ServicePlex is easily installed in conduit or cable tray. Best of all, like Service Pro X singles, ServicePlex is available in all industry standard colors, 14 gauge through 750 kc mil and XHHW-2, USE-2, and RHW-2. Hyperscale data centers often use suspended cable tray to eliminate the stress of mounting large volumes of cable to server cabinets. Cable drop-offs are positioned above each cabinet to waterfall cables to their connection points. Therefore, tray cable must be TCER rated per the National Electric Code. In other words, the cable is permitted to transition up to 6 feet without continuous support, exposed to free air. All ServiceWire tray cable is TCER rated. Tray cable is suitable for installations in cable trays, supported by messenger wire and open air, raceways, channels, conduit, and ducts. It is primarily used for power, control, signal, and to power lights and control circuits while protecting critical systems from potential voltage spikes. Tray cable is available dual-rated 600 volt/1 kV, shielded or non-shielded, with flame retardants, moisture, and chemical-resistant jackets. ServiceWire standard stock tray cable has a black PVC jacket but can be provided with a CPE or low-smoke zero halogen jacket. Data centers are usually very organized, sterile environments, heavily monitored for not only security but environmental concerns. These concerns limit the type and method of installing electrical wiring. Generally, there are 2 ways to install power in data centers. 1, an overhead tray cable, like we've already mentioned, or 2, under the floor. Feeder-size MC cables should be used when installing underfloor power. Underfloor power systems allow the data towers to be rearranged without the need to tear up floors and redo all underfloor wiring. MC cables are a major cost and time saver because you don't have to pull both conduit and cable. Just the armored MC cable, as is, off the reel, right to the termination point. MC cable can save up to 70% on an installation compared to traditional pipe and wire. Service wire offers feeder MC with XHHW-2 interconductors, an 8-gauge through 750 kc mil, 2 through 4 conductors, and 120 volt and 480 volt collar codes. Oversized grounds and outer PVC, CPE, or low smoke zero halogen jackets are also available. Now that you have an understanding of the applicable products, let's review what you need to know when bidding on a data center project. 1. Who owns the data center? Like I mentioned in the beginning, there are many different types of data centers. It is important that you know who the end user is and what type of facility they are building. By knowing if it is a Google, Facebook, or CoreSite job, for example, our ServiceWire team can offer you the proper material for the job. 2. Where is it located? Location can help you identify the scale and potential end user if the project has a code name. We can see what similar facilities are in the area and how best to approach the bid. 3. What is the project timing? When specifying wire and cable, timing is critical. If they wait too long to order, we may not be able to deliver per the request. If ServiceWire is not on spec, we may not have the time to contact the approving authorities, and we'll miss out on the job. Also, if we are specified, we need to know if it is a bid or buy and when the buy will occur so we can price accordingly. 4. What are the engineering specs? For each job, we need to know and verify the engineering specs for the grounding system, power, and cooling systems. Having the engineer specifications will help expedite the quoting process, as we will know exactly what they want and what to offer as an alternative. It will also help us determine upfront if additional spec work might be required. If you're looking to pursue a data center project, ServiceWire is your best choice. Our low-voltage copper cable is ideal for secondary power distribution applications where you need collared XHHW-2 single conductors, twisted service plex, TCER-rated tray cable, or large feeder MC cables. We offer a wide range of in-stock wire and cable, and our minimum order quantities on special make items is lower than the competitors. Plus, our quick turnaround times and faster delivery will get your project off on time and keep it on time every time. ServiceWire will even cut to length, provide custom packaging, and install pulling eyes when needed. When it comes to data centers, ServiceWire isn't just our name, it's what we do.